Welcome to a short lecture about the gorges and glens of the Finger Lakes in New York State. Our story starts during what's called the Acadian Caledonian Orogeny, and that is a mountain building event where a series of chunks of continental crust called Avalonia are being accreted onto or added onto North America about 415 to 360 million years ago during the Devonian period in Earth history. I want to point out also this is actually Africa, and Africa and North America are going to collide in part of our story, but they're not the beginning of the story. So the beginning of the story, again, is during the Acadian Caledonian Orogeny, and what's happening here is I'm going to zoom. You can see where the paleo equator is and where north is oriented. So you see that New York State here is actually located south of the equator during this period of time. And if we zoom in on New York, you can see that here is roughly the location that we're looking in, that the majority of New York State is actually underwater at this time. It's underwater, and it's part of what's called the Catskill Delta, or the Catskill Clastic Wedge. So what's happening is the Avalon terrain is being accreted onto North America, and sediments are being shed into what's called the Catskill Foreland Basin. So that's where our Finger Lakes are today. And as they're being shed in, there are a series of streams and tidal flats and things of that nature, where basically the sediments are being shed down from the mountains, the Acadian mountains here, into the Catskill Foreland Basin and building up quite a collection of sediment. Over 6,000 feet of sediment is deposited in about 14 million years during the height of erosion. Primarily, the sediment that's being deposited is sand and clay, and so therefore the rocks that form are sandstone and shale. Very cool. So, back to Africa. The next thing that happens is here is where Africa actually does in fact collide with North America. If this slide looks familiar, it's because it was part of the Rock City lecture as well. This is the Allegheny and Orogeny. It occurred about 300 million years ago or so. And as you can see, New York is a much drier place, and we were focusing primarily on the rivers down here in Olean, New York, when we talked about Rock City. And what happened instead in the Finger Lakes region of Ithaca and Watkins Glen is instead all of that compressional stress from Africa bumping into North America created a series of joints, vertical joints, that formed during the Allegheny and Orogeny. So we can see evidence for those joints in the sandstones and shales of the Ithaca region. And so this is a map. In fact, you're going to be using this map when you look at your assignment for today. And here is a map of Cayuga Lake. What you see here is a map of all of the known joints and faults in the region. And you can see that there is some definite patterns to them, right? There are some that are going sort of in this direction and in this direction. And then there's another set that kind of goes northwest to southeast. And so there are a series of joint patterns. Again, those are typically related to the Allegheny and Orogeny. Very cool. And so the joints we also see in the rocks of Ithaca and Watkins Glen. And so the joints show up when you have these perfectly flat intersections of rock here. Obviously that's not here, that's a man-made step, but here where you see the stream flowing directly in between these perfectly flat cracks. So these are horizontal joints, but we can also see vertical joints here where you have perfectly straight fractures in the rock. Joints are basically where you have fractures in a rock, but there is no movement. So if there was movement, it would be a fault. We can see that down here in the siltstones and shales here as well, where again you see these perfect angles of intersection of those joints. And again, these are the result of the Allegheny and Orogeny. So also on this picture, what you see are some of the really significant regional parks, including, but certainly not limited to, Watkins Glen State Park, which is well known not only for its waterfalls, as the waterfalls cut down through the soft shales and siltstones, but then also for these regions, which are called potholes. Potholes are where you have rocks that kind of swirl around in a circular area when stream flow is high, and it will carve out these circular regions called potholes. So that's this Watkins Glen State Park, and it's just a very short ride away from Robert Treman State Park. Again, you can see the joint controlled nature of these rocks as well, and these very sheer walls of the gorge in one of the many gorges in Ithaca. Taconic Falls State Park falls into this category, as well as Buttermilk Falls State Park. So why do we have so many waterfalls in this region? You've all seen the bumper stickers, Ithaca is Gorges. Why is Ithaca Gorges? Well, that is the focus of today, really. So here is a map of the Ithaca region, and here's Cayuga Lake. This is a shaded relief map. The cooler the colors, the lower the elevation. And so here is the inlet to Cayuga Lake. This is Fall Creek, which actually the Cornell campus, it goes right through the Cornell campus. Here is 6 Mile Creek, which has a bunch of which is full of gorges. Here's Buttermilk Falls State Park, which I just showed you a picture of, has waterfalls and gorges, and Robert Treman State Park. All right, so why does it look like this? Why are there so many gorges in such a small region? The answer is glaciers and base level. So this is what that region looked like about 14,000 years ago. You can see Cayuga Lake does not exist yet. In fact, it is full of a glacier. And at the front of the glacier, the Valley Heads Moraine is being deposited. You can see that there is meltwater from this glacier, though, and it fills in a lot of these valleys, and those are called proglacial lakes. Proglacial lakes mean in front of the glacier. And at this point, the lake level is about 1,060 feet above sea level, and we can tell that because we can find sand deposits that represent beaches all along the 1,060 foot elevation, which is cool. Well, we all know that glaciers started melting away significantly about 14,000 years ago. So as that happened, the glacial lake got larger, and these glacial lakes begin to intersect. And they form what geologists call Glacial Lake Ithaca. Glacial Lake Ithaca is about 980 feet above sea level. Now we know Cayuga Lake is going to be here, right? And this is going to be the inlet, but you can start to see some of these streams that are flowing down that look like they're in very familiar locations. So I encourage you to kind of go back and forth and just make sure that you see exactly what's happening here. So the glacier continues to melt back, and all of these glacial lakes merge along with the opening of the initial portion of Cayuga Lake, which geologists call Glacial Lake Newberry, and that has an elevation of about 900 feet above sea level. And this glacial lake exists for some period of time, but then, as we know, glaciers melt away, so the amount of glacial meltwater significantly decreases. We can see there's a very large delta here. Parts of this delta you can actually see on the Cornell campus, because if we move back to today, here is Fall Creek. Fall Creek is the creek that goes through that delta and down into Cayuga Lake. Let's just go back for a second. You can see here was the lake, part of the inlet to the lake, and that becomes 6 Mile Creek. Whoops, sorry. Here is where we have Buttermilk Falls today, and you can see that Buttermilk Falls used to be a stream that flowed into this glacial lake, and here where we have another stream flowing into that glacial lake, when we go to today, that becomes Robert Treman State Park. So what happened between here and here? So remember the idea of base level. Base level is the concept that rivers will really only erode to the elevation of the body of water that they flow into. That's base level. So for example, the Genesee River, its base level is Lake Ontario, which has an elevation of about 250 feet. But then what you can see is that between the time of Glacial Lake Newberry and today, base level has dropped significantly. The way that, because here the elevation of Cayuga Lake is 385 feet, remember Glacial Lake Newberry was 900 feet. So the way that rivers respond to their base level dropping is they start to downcut through their channel. And so as the base level or the elevation of the body of water that these streams flowed into, as that base level dropped, those streams responded by directing all of their energy at getting close to base level as quickly as possible. And so that led to the vertical downcutting that creates all the gorges that Ithaca is so well known for. Good story. Very cool. This project definitely made me want to go to Ithaca as soon as possible. I hope it made you feel that same way. Thanks.